Hello and welcome. Today I'm going to be providing you with an introduction to factoring polynomials. In this lesson, we're only going to be factoring monomials. However, in further lessons, we're going to go into factoring things like binomials and trinomials. First, let's recall, what are factors? Factors are the numbers that are multiplied to find a product. Remember, a number is divisible by its factors. For example, let's go ahead and factor 12. 12 can be factored into 12 times 1, or 6 times 2, or 4 times 3. Now, prime factorization is the group of factors of a number that are all prime. Now, if you notice, 12 times 1, that is not prime factorization because 12 is not prime. 6 times 2, that is not prime factorization because the 6 is not a prime number. And 4 times 3, that is not prime factorization because the 4 is not prime. So what I'm going to do is I'm going to create a factor tree to break my 12 down into all the prime factors. I'll start with maybe 6 times 2. And my 6, I can break that down further and it becomes 3 times 2. My prime factorization consists of all of the numbers at the ends of branches. So the 12 is not at the end of a branch, I'll ignore that. The 6 is not at the end of a branch, I'll ignore that. The 3, the 2, and the other 2 are all at the ends of branches. So these make up the prime factorization of 12. 2 times 2 times 3. I'm going to go ahead and do the first 2, and then I'll ask you to do the second 2. To write the prime factorization of 60, again, I'm going to create a factor tree. 60 can break down into 12 times 5. 12 can break down into 6 times 2. And 6 can break down into 3 times 2. Now the prime factorization of 60 consists of all the numbers that are at the ends of the branches. So I'm going to ignore anything that is not at the end of a branch. 60, 12, and 6. 3, 2, 2, and 5 are all at the ends of branches of my factor tree, so this makes up my prime factorization. None of those numbers can be broken down any further. So writing them in order, I have 2 times 2 times 3 times 5. When you multiply all these together, you will get 60. For 49, I'll start by breaking it down into 7 times 7. Now if you notice, I can't break either of these numbers down any further. So this is our prime factorization, simply 7 times 7. When you multiply those two together, you do get 49. Go ahead and pause the video and take a second to try the next 2 on your own. For the prime factorization of 40, you should have 2 times 2 times 2 times 5. And for the prime factorization of 33, you should have 3 times 11. Now please remember to write your factors in order from the smallest to the greatest. We're going to go into finding the greatest common factor for a pair of numbers. So what we are going to do is we are going to find the largest number that each of these can be divided by. We start by factoring each of the numbers, all the way down into their prime factorization. 24, I can break that down into 12 times 2. 12 can be 6 times 2, and 6 can break down into 3 times 2. 60, again, I can break that down into 6 times 10, 3 times 2, and 10 can break down into 5 times 2. I can't break down those numbers any further. So my prime factorization of 24, looking at all of the numbers that are at the ends of branches, I ignore those that are not, and I write my numbers in order from least to greatest. So 2 times 2 times 2 times 3. For 60, I ignore the 6, the 10, and the 60. And my prime factorization in order from least to greatest would be 2 times 2 times 3 times 5. Now what we are looking for in order to find the greatest common factor is what factors do each of these numbers have in common? Well, they have a 2 in common, they have another 2 in common, and they have a 3 in common. When I multiply these together, 2 times 2 times 3, I get a 12. So both of these numbers can be divided by 12. Let's test it out. If I take 24 and divide it by 12, I get 2. If I take 60 and divide it by 12, I get 5. This is the largest number that both 24 and 60 can be divided by. I'm going to do it one more time with 18 and 27. 18 can be divided into 3 and 6. 6 can be broken down into 3 times 2. 27 can be broken down into 9 times 3. And 9 can be broken down into 3 times 3. For my prime factorization of 18, I am going to ignore everything that is not at the end of the branch. So I ignore 18 and 6. And my prime factorization of 18 from least to greatest is 2 times 3 times 3. For 27, I am going to ignore in my factor tree the 27 and the 9. So my prime factorization is 3 times 3 times 3. I'm going to look through each of the prime factorizations and find the common factors. They share a 3 and they share another 3. Multiplying those together, I have 2 3's that they share, which multiplies to 9. So what we just found is that we can take 18 and divide it by 9. When we divide, we get 2. When we divide 27 by 9, we get 3. So 9 is the greatest common factor of 18 and 27. It is the largest number that you can divide both of those terms by. Go ahead and take a moment to pause the video and try these next two on your own. For 12 and 16, I found a greatest common factor of 4. When I factored 12, I got the factors 2, 2, and 3. When I factored 16, I got 2, 2, 2, and 2. They shared 2 2's, which multiplied to get 4. So the greatest common factor is 4. For B, when I factored 15, I got 3 times 5. When I factored 25, I got 5 times 5. They both share a 5, so my greatest common factor between the two is only 5. Now our last thing to discuss for today is what if we have variables as part of our terms? Well, we factor it down the same way. 3 times x to the third. Well, I can break that down into 3 times x times x times x. Since x to the third can be broken down into x times x times x, I just did that by writing all those x's out. 6 times x squared. Well, the 6 can be broken down into 3 times 2, and the x squared can be broken down into x times x. So my 3x to the third, I can write as 3 times x times x times x, while my 6x squared can be written as 3 times 2 times x times x. They share a 3, and they also share an x and another x. So both of these terms have a 3, they have an x, and they have a second x, which makes our greatest common factor of the two 3x squared. If you look back to the original, 3x to the third, there's a 3 there, and there's at least an x squared there. It has a few more x's, but that's okay. In your 6x squared, there's a 3, and there's also x squared. So what both of these have in common is the 3 and the x squared. We'll break down our 4x squared to get 2 times x times x. And 5y to the third is 5 times y times y times y. So 4x squared, that broke down into 2 times x times x, while 5y to the third broke down into 5 times y times y times y. Now notice they don't share anything in that list of numbers. Since I'm not able to circle anything, what we do say is since everything can be multiplied by 1 and not change itself, our greatest common factor is only 1. Go ahead and take a moment to pause the video and try these next two on your own. For the first, when I factored 18g squared, I got 2 times 3 times 3 times g times g. For the 27g to the third, I got 3 times 3 times 3 times g times g times g. Identifying what they had in common, I found they had 2 3's and 2 g's, which multiplied to find my GCF of 9g squared. For b, when I broke down my 16a to the 6th, I had 4 2's and 6 a's. For my 9b, I had 3 times b. Looking at that list of factors, there is nothing in common. Since everything can be multiplied by 1, and it does not change, my greatest common factor of these two terms is simply 1. That's all I have for you today. Thank you so much for watching, and I hope you enjoy the rest of your day.